Okay, so let's get started. Thank you everybody for coming. My name is Vincenzo. I am a software engineer for the MariaDB Foundation. And today I'm going to give you a brief overview of the new developments in optimizers. We've already heard Øystein's talk about histograms. So that's something that MariaDB has in a different format in 10.1 and onwards. And now we're going to compare a few of the other things that optimizers can do. So first of all, what is the goal of the query optimizer? So we want to get, given a certain SQL query, the fastest time possible when executing it. And we have different tools to do that. We can choose to either cache some data before we actually compute the full result. We can do some index lookups and get that data faster this way. Or we can try to rewrite your query in a more efficient manner so that we can query it faster. So now, the problem is that the number of possible plans grows exponentially with the number of tables. It's actually a factorial number of tables, but let's say that it's exponential. And in a perfect world, a query optimizer should be able to give you the best result all the time. Unfortunately, that's not the case. For many queries, it does happen, but there are certain instances where it works quite badly. We're not going to be too concerned about those for now, but any optimizations that we do, we try to reduce the number of possible queries which behave poorly. So in order to explain what kind of optimizations we're doing in recent developments, I need a bit of background. So first of all, a derived table in MySQL is any sort of table which you can find as part of a subquery in the from clause. Whenever I say derived table, it's either this or a view as part of the from clause. So a view is basically the same thing. Here's our query example. We want to get all our customers which had orders, which had large orders, so greater than 1 million entries in their order. There's only a few customers, so that's why they're VIP customers. And the orders have to be from October start to end, 2017. How would you execute this in a naive fashion? Well, we first compute the result in this table here. So this is October orders. We just do a filter on the orders on the date. And then we try to join this table with VIP customers. Using the join condition, the amount must be greater than 1 million. So here's the set of October orders that have amount greater than 1 million. That part will enter the join with the VIP customers. And you get your result. However, we can do better than that. And this is something that MySQL and MariaDB and obviously Percona, since they're based on MySQL, also do. We rewrite this query because we can. And this data, this condition here, it's only based on orders. And if we move this condition outside of the subquery and just replace the custom table with the orders table, we're going to get this query. So now the optimizer has a more general view of how we actually want to query the data. We have all the conditions in one place. And this leads to a better query plan. If you do explain, you will see that we only have two tables visible, VIP customers and orders. We don't see October orders anywhere in the explain plan. And the execution goes as follows. We get the orders. Then we get the October orders and the amount. There's an intersection happening, so there are orders that are not in October, which have greater than 1 million amount. Only the intersection of all these conditions will enter the join operation. And then this gets joined with VIP customers. So instead of first computing everything here, we just do one table scan over orders and one over VIP customers. There are some tricks to buffer results, but I'm not going to go into too many details here. So conclusion is that merging is good. It simplifies the query. And as I said, it works in all stable versions of MySQL or MariaDB. However, there's a problem when aggregation comes into play. we can't use it when aggregation happens. Because if you rewrite a query which has an aggregate function in the subquery, results are not what you expected. So here's an example. We want the October totals, so all the number of orders, the number of items ordered per customer in October. If we were to join this query inside the main one, you would actually start aggregating stuff in this one, and you don't want to do that. You actually want the totals for one customer in this case, which is customer ID equal 1. But we have group by customer ID. So we can make use of this here. All right, so we have lots of customers. We don't want to get all the totals just for one customer. So we make use of this group by column here, and we identify this condition, customer ID, and we push this condition all the way to the where clause here, because we have this group by column here. So now, when aggregating, we only aggregate one customer. So we get our orders, we get only customer 1 orders, and then we sum those up. So instead of doing aggregation over the full data set, we just aggregate one customer. This optimization is available in MariaDB 10.2. And this tactic also works for window functions. If you were here from the start, you've seen that we have window functions in MariaDB 10.2, and there is also window functions coming in MySQL 8.0. So we can push the same condition if we have a window function with a partition by clause here. So partition by means that you compute this rank sequence for each customer. You can see here customer ID equals 1 has orders 1, 2, 3, order ranks. Same for customer 2, and so on. And we don't want to have to compute this rank column for all of the table if we're only interested in customer 1's top 3 orders. So we only want this here. And because we have this equality condition here, and there is this partition by clause here, we know that we can simplify the query and push this part of the condition all the way up here in the where clause of this query. So if you push this, you only get to compute this part, and this information is not even accessed. Okay, so if you compare how execution would happen currently in MariaDB 10.2, which is the stable release, MySQL 8.0, which has window functions, MySQL 8, they would compute all top 3 orders for all customers, and then you would get the rows for customer ID equals 1. In MariaDB 10.3 and also in Postgres, we've also tested how Postgres does it, you would only compute the top 3 orders for customer ID equals 1. And in some cases, this can be much faster because we can make use of indexes to identify the rows for that particular customer. Make sense so far? Okay, either I'm very clear or nobody's understanding anything at all. Okay, so final optimization. I think the name for this is not quite fortunate. So we're probably going to change it. So for now, we call it split grouping for derived. So what happens here? Where we have a similar query to the one before. We have a group by statement. But because there is no equality, we don't filter by one customer ID. We have a range of customers. Here, see, we have customer name in John and Bob, but we don't have customer name inside orders. We have customer ID. Okay, so we have the join condition here. Customer ID equals October totals customer ID, and we filter by customer name. So we can't do condition push down immediately because there is no column customer name here. However, we can be smart about this, and actually let's first look at how we are not smart. So when we're not smart, we do a sum of everything. So for all customers, we get the sum, and then this means we get the October totals, and then for each customer, we filter only Bob and John for both and join them. So we have to do aggregation over the full orders table. Again, not good. This gets big very fast. As you see, we don't need customer X. When we're smart, we actually look at customers first. We see which customer IDs we are allowed to use, and we only aggregate those customers. So we can compute a sum for Bob, and we can compute a sum for John. And this way, we completely ignore this part of the table, as well as this part of the table. There are some requirements for this, though. In order to actually do this, we have to have a join condition here. So we have to have something that links orders to customers. In this case, customer ID is linked, is the column that links the two tables. And we also must have a index on the group by column to be able to quickly check if the customer that we're looking for is actually in the table. So here we want to have an index to check if is Bob in orders, but is Bob's ID in orders. If you don't have this optimization won't actually work right now. It's still in the beginning phases, so we haven't really optimized this for all cases. We only apply it when we're definitely sure that it will bring a speed up. Otherwise, we don't use it because we're not sure if it's going to produce a better query plan. And to look at, to see how features stack up, well, we have derived table view merge. This is the first thing we talked about in all stable versions. Condition pushdown is a MariaDB only specific feature. Window functions are coming into MySQL 8.0. And I haven't personally checked, but I believe merge actually works with CTEs too in MySQL. And also condition pushdown for partition by and split table grouping is only available in MariaDB 10 free. So we're hoping that MySQL can also implement this, because if more users get optimizations, it's better for everybody. Obviously, this is not a comprehensive comparison. I'm not trying to show that MySQL doesn't have any features or that we have a lot more. This is just on the features I talked about during this talk. This is actually a overview of how things work. This is basically what I talked about. If you want to reread this summary, it's available. I will post this talk on the FOSDEM link, so you can download it there. Okay, that's all I had. Thank you very much.
We have time for questions.
Yes. I actually have more slides, possibly, but it's a bit difficult. So if people are interested, I can talk more about it offline. Yep. Yep. Go ahead. So is it this one? So I'm not really sure I get your question, so let me try and rephrase it. So the question is, why don't we have a where clause inside the view here, right? Yeah. Well, for example, if you try to make an application for users which works for multiple, say you're in a company and you want this view to work for multiple departments. Maybe you don't want to filter by a specific user for that department. So that's why. Well, maybe the example is not, the example is to showcase the optimization possible. It's not to show that this is the way you should actually write all your queries. Okay? Yes, you can optimize it manually, but the idea from the start of the talk is this. So, in a perfect world, any query should run fast. Okay, so that's what we're trying for. Even if you shoot yourself in the foot. Okay.
You were very clear.
Okay. Thank you.